Hello everyone. Welcome to Introduction to Operation Research in Python. In this video, we will look at how to solve an optimization problem using Python. And to demonstrate that, we will use a simple example of animal feed mix. So let's get started. The the simple example that we are taking in this for this video is the animal feed mix. What we want to achieve is that to to manufacture or to create the animal feed, there are different ingredients that are available. These ingredients have the different properties. For example, they have different protein in it, the fat, fiber, moisture, or they have the different properties. Also, the availability of the ingredients is different. We want to produce or manufacture the animal feed mix, which has the blend mix should have certain properties and produce these blend mix at the minimum cost. That's the objective. Now, moving on in terms of the availability of the data, what we have is there are four ingredients that are available for the animal feed mix. These four ingredients have the different cost. They have the different properties. For example, the protein content, fat content, fiber content, and the availability of these ingredients. After mixing these ingredients, the blended mix that is produced should have these properties. For example, the blended mix should have the minimum protein percentage of 15%, the fat percentage of 5%, and there is no maximum requirement for the protein and fat, but the fiber requirement should be less than equals to the 8% in the blended mix. Given this data, let's try to formulate this problem statement into a mathematical equation. We talked about the optimization framework where we talked about three different components for any optimization problem, like decision variables, constraints, and the objective. So go feel free to check that out, that video, if you have not seen that. So moving on, how to formulate this into an mathematical equation. First, let's define the sets and the parameter. So let's say the I is the set, which is the set of all the raw materials or the ingredient, and we will use the I as an index. We have the cost for each of those raw materials. We also have the properties of those ingredients. For example, the protein percentage, fat percentage, and the fiber percentage. Now, to formulate this into a mathematical equation, let's derive the decision variable. So we want to find out how much to mix these ingredients. So the decision variable for us is the xi, which would say the amount of raw material to mix for, in this case, which would be the xi, and that is the decision variable. The objective function for this problem is minimize the total cost, and the cost would be the summation over xi multiplied with the cost I. Now we can write the constraints. The constraints are simple in this case. So the total, and we want to produce the animal feed to 100 kg, let's say. So the total sum of xi should be equals to 100. That's the first constraint for us. And then we want to say the blended mix, which is blended mix has the property, or the protein requirement in the blended mix should be greater than equals to the blended mix protein requirement, which is in this case was the 15%. So we are writing the constant as pi multiply pi is the protein content in each of those ingredients, and multiplied with the xi, which is the quantity to be blended mixed in. That will give us the blended mixed protein content that should be greater than equals to the blended mixed protein requirement. Similarly, we will have this constant for the fat, and we will have this constraint for the fiber, but it would be for the fiber, since we have the maximum requirement, we will write this as less than equals to, and this would become, let's call this parameter as ff, and this will become blended mix fiber and max. So these would be the constraint. Now let's see how to solve this using the Python. So I'll just move on to the my VS Code. Here I have already input. I have already modeled the input data, which we just saw on the PowerPoint, and I'll be using the pulp library. And to install the pulp library, you can simply do pip install pulp, and that would install the pulp library, and then you can do the import. So here we have the set, which is the ingredients that are available. In this case, the corn, soya, barley, and bajra. We also have the cost, the availability of the ingredients, which is in terms of the kgs, and the different properties. For example, the protein content, this is the protein content, this is the, in this case, this would become fat content, and this would be fiber. So to model this into in Python, what we will do is we'll use the pulp, and I have created a model by declaring pulp.lp problem, and I gave a name to this problem, and we are trying to minimize the objective. So we will put here pulp.lp minimize. Now let's declare the decision variable. So the decision variable for us would be let's say the x equals x equal to pulp dot lp variable, and then we will say, since we are defining this variable for each of the ingredients, so we'll declare this as a dictionary, and then let's name this variable as x, and let's name this variable as x, and then what we will say, we'll create this variable for all the ingredients. So the index for all the ingredient is I, and we will loop the I in set I. That would become the decision variable in our case. Now we also want to put the lower bound and the upper bound for the decision variable. So in this case, the lower bound is obviously 0, and the upper bound is 100, because we want to let's not put the upper bound. We will implement that through the constraint, but we can define this variable type and the category, which is through the category, and this would be the continuous, and here it would be C capital continuous. Next, we will try to write the objective function, and the objective function was summation over xi multiplied with the cost. So model plus equals to, which means we are trying to add an element to the model, and we will write pulp dot lp sum, and then we will say, so the coefficient for the objective function is the cost, and then cost I multiplied with variable xi, and we will say for I in I. This would become the objective function for us. Now let's write the constraint. The first constraint that we want to write is the total blend mix quantity to be 100. So let's write that. Model plus equals to, which means we are again adding an element, pulp dot lp sum, and then summation of all the ingredient, which is the xi, and then we will say for I in set I should be equals to 100. And in this case, we need to do equals to, and we can give this constraint as a name, for example, total weight. Now also let's write the second constraint, which was the protein the blend mix protein, blend mix fat, and the fiber requirement. So let's do model plus equals to pul dot lp sum, and we will say xi multiplied with, let's write for first for the protein, which means the p here, parameter p I, and we will say for I in set I should be greater than equals to the minimum protein requirement for our blend mix was 15%. So 0.15 multiplied with 100 because we want to produce the 100 pounds. Now also let's also write the so this is the protein requirement. Let's also write the fat requirement, and in case of the fat we have the FA, and the minimum fat requirement was the 5%. Now let's also write this constraint for the fiber, and for fiber the parameter that we have declared is Fi, and we have the maximum content for the fiber, which is the 8%, so we will say less than equals to 0.08. Now this has modeled all the constraint except the availability constraint. So let's also write the availability constraint, how much of this material is available for us, and that would be for each of the ingredients. So let's do for I in set I, then let's write model plus equals to x I should be greater than equals to how much quantity is available, which is the availability parameter here, and we will say availability for I. So we have defined all the constraints. Now what we'll do is we'll try to solve it. So to solve it, let's say model dot solve. This will solve the model, and what we will do is we'll try to print the output. So to print the output, let's write print output total cost equals to model dot objective. So what's the total objective for us? And we need to do this as pul dot value to make sure we get the value for the after solving the model. So that should be the total cost for the blended mix to produce the blended mix. And let's now print the how much of each of the ingredient the optimizer is recommending. So for I in set I, then let's say the print how much of this we need is, so let's write this comma x I dot variable value. So which is the syntax for that is var value, and this would be again in kgs. Now let's try to solve this. So what I'll do is I'll run this in the command, and what it says is that there is some issue. The issue is equals to. So we're getting some issue in the here because we have not put the comma here. Let's rerun. Let me clear everything and then rerun. So I'll rerun the problem, and as you can see the solution, it has found the optimal solution here, and the total cost is 1012 rupees, and it says this much quantity for each of these ingredients should be used.